For example, in kinematics equation, you know how to calculate the velocity, the initial and final velocity, or the displacement, things like that. Newton's laws of motion, density, buoyant force, etc., etc. But what is important is not knowing just the basic formulae, but use those formulae to create your own what I'll call special cases. Okay, so special cases are like where you know specific information. For example, if you take a case of an object which is dropped from a height, okay, from the top of a building, and it reaches the ground, and you know, typically you can be asked questions like, you know, how much time did it take to hit the ground, or what was the velocity when it reached the ground. Now, all of these things can be found from kinematics equation. I think you already know that. But the thing is, this situation is going to occur multiple times. And every time if you put the values in kinematics equation and solve it, you will waste maybe 10 seconds, 15 seconds every time. And so all that time adds up very quickly. And also there are chances to make mistakes and things like that. So if you have all of these special cases ready, prepared as part of your revision formula sheet, then that will save you a lot of time. Okay. Another very typical example is in the case of density and buoyancy. You know, we often have some object which is floating in liquid. Then you should have the formula ready for, you know, what is the density of the object versus the liquid. So there is we will derive this formula today. That what is the ratio of the volumes of the submerged and the total volume. So all of these are shortcuts which will save you time. Okay. So all of this is important for this kind of exam because uh, time management is also one of the important aspects of doing well at an exam like this. Okay. And then the last thing that I think we should be well prepared is the mathematics part. So as we saw in the previous page that, you know, step two is solving the equations. So you should know that part very well. It should not be the case that you know the physics, but you got stuck in the mathematics or you made a mistake in the mathematics. So that should not be the reason why you were not able to solve a problem. So in mathematics, the basic things that you need to know to solve these problems is like basic linear equations, quadratic equations, simple simultaneous equations, like just two variables, very rarely three variables. And then some basic knowledge of vectors, like how to add vectors in one dimension and two dimensions. And some geometry formulae, like, you know, typical volumes, area, surface area, and things like that. So nothing advanced. All of this you already know how to do at the school level. Just, you know, it should be very efficient for you. It should not take time for you to do any of these things. Like if you just take the example of quadratic equations, you should know multiple ways to solve the equations, right? Like there is factorization. You know that b square minus 4ac formula, and you know, quickly looking at the equation, you should formulate a strategy that what will give me the fastest and the most high probability of correct answer. You know, so picking that strategy quickly is going to, you know, give you the advantage, because understand that competition is very high. That there will be lots of students trying for this exam. So every small edge that you can get, you should take it. Okay. Okay. So this is the again mostly general ideas about how to prepare for an exam like this. So we'll start to solve the questions, but before that, I wanted to also introduce one concept which is called degrees of freedom. This is somewhat advanced concept, but I think it will be very useful to know this idea because it will help us to, you know, look at formula in a different way. So, like generally speaking, the definition which we can give for this degree of freedom is that if you have a situation or a system which has many variables, then how many of those variables can be given, and based on that, you can find the rest of the information. Okay. So, I mean, to illustrate this point, let us take something like simple interest. Okay. So, like, I think we all know the formula for simple interest, that simple interest is P principal into number of years into rate of interest upon 100, right? And then the amount is what principal plus interest, right? So in this, you'll see that there are total five variables involved, right? The principal, the years, rate of interest, the actual value of the interest, and the amount. And then out of all these five, if I have given any three, right? Any three are given, then I can find the others, right? That is typically how the questions are. That in the very simple case, the P, N, and R are given, but it can be much more complicated than that also, right? But the point is that you need to know three of these values. Only then you can find the rest. So we say that the degrees of freedom of this system is three. Okay. It is as simple as that. Nothing more than that. But the same is true for multiple situations. Like if I just go back to my slide. So for example, let us take kinematics equation. Okay. So in kinematics equation, you have all these variables, right? The initial velocity, the final velocity, the acceleration, the time, the displacement. So out of all these five, if any three are given, then you can find the others. Okay. So that is what the kinematics equation allows us to do. So knowing that degrees of freedom and knowing every combination, that if I give you these three quantities, how you will find the fourth one. So knowing all those formulae in your formula sheet is very important. Okay. So this kind of analysis you can do for every equation or every formula that you have in physics, or in fact, for that matter, even in chemistry and mathematics. Okay. So just keep this in the back of the mind that, the degrees of freedom are going to matter in lots of cases. Okay. So just to give you a snapshot that how, if you want to prepare a formula sheet, what are the things that you would like to include. So this is the most basic version. This is not what I want you to copy, because these are the formulae which are given in at the school level. But this is a starting point. That, for example, in kinematics equation, you have the basic equations, right? How to calculate initial and final velocity, displacement, things like that. Then, like this second line was the one which I was talking about. That if I throw an object from the ground, how long does it take to reach the top, and what is the velocity and things like that. And in fact, to this you can also add the what is the kinetic and potential energy of the object, right, when it reaches the top. So those kinds of things. Then in terms of forces, just knowing the basic like laws of motion, like basically Newton's laws are just saying that if you add up all the forces on any given object, then that will be equal to the mass into acceleration. And the forces can be of various kinds. That it can be gravity, it can be electrostatic force like the attraction or repulsion of charges, it can be buoyancy, etc., etc. Okay. Then momentum laws and energy conservation laws, like again, very basic things that, and it is very easy to create questions on these concepts, right? Because, typically you have some objects which are moving. Initially, you know the velocities, finally, you know the velocities, and you can equate the momentum, for example. So we will do some examples of this also. Density and buoyancy, again, this formula which I mentioned just a few minutes ago, that the ratio of the volumes of the two that are displaced versus the total object. So we will derive this formula in today's questions. Then for electric circuits, like Ohm's law is the basic thing, but using that to find equivalent resistance, I think you must be knowing this in school already, like how to find the series and parallel resistances. And then specific heat and latent heat, for example. So, the last batch, actually, students had lots of questions around this. Many students are may have the confusion that what is heat and temperature, that how are they similar or different. So if I have time, I will explain this in more detail. But again, that concept is not that important to solve the problems. So we can just solve the problems based on the simple idea that total energy remains constant. And so you just equate the total heat gained by one object, that has to be equal to the total heat lost by another object. Okay, something like that. And finally, optics. So again, optics, I will dedicate a fair amount of time, because this lens equation can be confusing many times. Because as it turns out, there is not one sign convention. There are multiple sign conventions. And I think in school we are using what is called a coordinate signs. And after you start, preparing for JEE, you have to use a different so-called Gaussian sign convention. So we should explain that properly. Okay, so this was just an overview of all the topics. This is the bare minimum that you should know, I would say that. And then based on this, as I said, finding your own special formulae that will help you to save time. Okay. But again, don't use this as a ready reference. Don't just copy this sheet and think that is all you need to do. This is my formula sheet. You should write your own independent formula sheet, which only you can write. because that is how you have organized things in your mind. You cannot copy somebody else's formula sheet. That will not be useful for you. Okay. Okay. So these are the two